Good morning, ladies and gentlemen. Welcome to this new semester. I hope you are fine, given the extremely abnormal circumstances. Well, yeah, what can we say? Just a few words before we start the course. First of all, I want everyone to attend the sessions. Now, let me tell you how the course will be conducted. There will be videos, recorded videos that will be posted on Moodle soon, okay, for all the sessions. And you can watch them as many times as you want. And we will have, for the time being, we will meet once per week, which is on Tuesdays, live sessions. What we shall be doing during these live sessions is you can ask questions, of course. We will solve some problems. I will just go over the material quickly. But the main course is recorded, okay? So that you can have access anytime to the lectures, all right? You can, of course, also ask questions via email, all right? If it's very urgent, you can definitely ask questions via email. Soon the videos will be posted. They are not ready yet, some technicalities, etc., as you know. Another thing is, please don't miss too many sessions. It's for you, not for me. You need a book. Definitely you need a book, because you will be referring to the book for problems, etc. By the way, the whole course is on Moodle via handouts and explanations. And when Moodle is activated, you will have access to them. So no problem. Very, very important is that you practice in this course. It's a quantitative course, ladies and gentlemen, and you have to practice, okay? By practice I have some suggested problems that are placed on Moodle. Please try to solve as many of them as you can, right? And we shall also solve problems in the classroom when we meet. Without practice, it doesn't work, that's for sure. All quantitative courses. Let's see, we are going to have some exams. Basically, we will have 2 quizzes, God willing, of course, a midterm and the final. The syllabus will be posted also on Moodle. Don't miss exams. By the way, the exams are online, and try not to miss exams. There are no makeups for the quizzes and the midterm. The final exam, you know the procedure, there's a procedure, you should write a petition, and then it goes to the Student Affairs Committee, and so on and so on. So try not to miss, as much as possible. Your exams will be monitored via responders, so you know that. Anyway, it's a university policy, so we are going to follow it. What else should I say? I think that's it. That's it, basically. Okay. And whenever you have questions, just keep asking me or send an email, and I will respond as soon as I have access to the internet. Okay. Now, let's see. This course, of course, is a required course, so you have to take it. Many say it is a difficult course. It's not. Believe me, it's not. You can make it difficult. I tell the students, you can make it difficult by not studying. Actually, any course is difficult if you don't study for it. So please do not accumulate too much material. You have a lot of help. The videos are there. You can watch them over and over again. So yeah, there's no reason to get bad grades in this course, definitely. Right. So let's see, what is statistics? the course is statistics, and what is statistics. And of course, if you were present in the classroom with me, I would have answers like, Miss, it's probability, it's charts and graphs and so on and so forth. Ladies and gentlemen, the core element of statistics is numbers. We deal with numbers. Some synonyms that we shall be using during the course: observations, data, measures. These are all synonymously used, but of course the simplest word is numbers. So if we want to give a definition for statistics, we shall say it is a collection of tools and means and methods by which we obtain data, we obtain numbers, we obtain observations. We analyze them. For what? For decision-making purposes, okay? For decision-making purposes. Decision means uncertainty. We are living in a world of uncertainty and choice decisions, so we have to make decisions. Okay? A few definitions that we shall be using throughout the course. One is the definition of a statistical population, henceforth referred to as population. And when we say population in this course, it means it's a statistical population. Okay, so I'm not going to say every time statistical population. I'm just going to refer to it as a population. Population, of course, what is the idea of population? It is a totality. In the case of a statistical population, it is all the possible observations, the possible observations having the same characteristic of interest. To whom? Of course, to the eye, to the statistician, to the analyst. Okay? All. That's very important. So if the characteristic of interest of the statistician is salaries, okay, let's say bank employees, right? So the population will consist of all the salaries of all the bank employees, not a single one missing, all of them, right? Next is the idea of a sample. A sample. Sample is simply part of a population. It is part of a population, okay? Now, in real life situations, do you think we shall deal more with populations or with samples? Definitely samples. It's very, very difficult to get hold of populations. The size may be very large. It might be very expensive. And we shall, of course, explain further in due course. But definitely, logically, we deal basically with samples, not with populations. Okay? All right. A few words about types of data that we deal with. Okay? The first one is what we call nominal data. Nominal from naming. We just name red, blue, green, right? These are names, okay? The second type is what we call ordinal data. Ordinal is from ordering. Actually, you are living in a university and there are definitely the classes: freshman, sophomore, junior, senior, graduate, okay? Well, there is an order. Freshman, sophomore comes after freshman, junior comes after the sophomore. There is an order. Now, both with nominal and ordinal data, the four mathematical operations don't make a sense. Okay? I mean, when you are saying green and blue and white, you cannot say, I mean, it doesn't make any sense to say blue plus white. makes what or gives what? Doesn't make any sense. Or even with the ordinal, freshman plus sophomore doesn't give you junior or senior, not at all. All right. So no operations, no operations. The next one, of course, is what we call interval data. Interval data, we start dealing with numbers, but again, the so-called arithmetic operations don't make much sense. An excellent example of interval data would be the temperature, weather temperature. Now, let's say there is 20 degrees Celsius and 40 degrees Celsius, right? Of course, arithmetically, 40 is 2 times 20. Okay, that's right. However, a temperature of 40 degrees, okay, doesn't mean it's twice as hot as 20 degrees. 20 degrees is quite cool. 40 degrees, you start boiling, as we are doing now, no, with this weather. Last but not least, ratio type of data. Our world, ladies and gentlemen, the business world and many other fields, ratio type of data, the 4 arithmetic operations make perfect sense. There is a well-defined 0, okay? I gave the example of salaries of bank employees. Well, if I have a salary of 100 liras and a colleague has a salary of 200 liras, it doesn't mean that 200 is just 100 times 2. It means my colleague can buy twice as much as I can do. A salary of 0 means there's no salary. It's the non-existence of the characteristic of interest, okay? In the business world, we deal basically with the ratio type of data. Okay? Doesn't mean that we don't deal with some other types, we do, but basically we deal with ratio type of data. All right. Let's see how the structure of the course is. Now we defined the idea of a population. We said all possible observations having the same characteristic of interest. Populations are divided into 2 major types, what we call quantitative populations and qualitative populations. We shall deal basically with quantitative populations, ratio type of data, quantitative populations. Sometimes we shall refer to and deal with also qualitative populations. And of course, the same thing applies to samples, because we did agree that most of the times we deal with samples, we don't deal with the entire population. Okay? Now, where do we get data from? Where do we get observations from? Where do we get information from? Definitely from what we call sources. Sources. Now, the source depends on what we are dealing with. So if I want, for instance, to have grades of students, I will go to the registrar's office. They have all the grades, everything. If I want an idea about salaries of bank employees, then I will go to the HR department of banks and I will tell them, give me the list of your employees and their salaries. Okay? However, if I want to know how much a person spends per month, then the only way I get the information is from going to that person and asking, how much do you spend per month? There are no HR, there is no record, there are no articles, etc., etc. I have to go to the person and ask the person, tell me, how much do you spend per month? So depending on my analysis, on what I want to do, I will refer to the proper source. All right, now, ladies and gentlemen, once I get the data, okay, before I do anything, before I start analyzing, they are in the form of raw data. Raw data like raw materials. If you want to have to make bread, for instance, the raw material will be wheat. Okay, raw data. Well, anytime you get the raw data, the first thing you do, and we should do it, we all do it, okay? The first thing you do is array your data. Now, I don't know if I ask anyone what an array is, probably many of you will know what an array is. An array is simply ordered data, ordering. Well, you do know that to order the data, there are two ways of ordering the data, either ascending or descending, okay? Ascending means you start with the lowest observation, the smallest observation, and you move up. Descending is you start with the highest, largest observation, and you move down. Now, definitely, if I ask which one is better, well, better, there's no better. It's what you like to do, okay? There is no good and bad in statistics. Basically, whatever is bad, we don't want it, we have thrown it away, okay? So there's no good and bad. But usually, the ascending order is preferred, i.e. we start with the lowest or smallest observation and we move up. So you will see that most of the arrays are ascending order. Okay. Now, by the way, I like to, and I do refer to AUB for examples that we shall be dealing with, grades and students, right? So suppose I have 15 students in my class, all right? Well, when I array my observations to get an array, so array is both a verb and a noun. When I array my observations, I have a pretty good idea about the grades of my students. And most probably, eventually, I'll have to present a report to the upper administration as how the students are, how are they doing, what are their standards, and so on and so forth. So with 15 students, once I look at the array, I know quite well how they are doing, the individual grades. I will look at the individual grades. The idea, ladies and gentlemen, of what we call ungrouped data analysis. Ungrouped data analysis. However, if I have something like, I don't know, 200-300 students, even if I array my grades, right? I start with my lowest grade and I move up to the highest grade, fine. And I read them, right? I read my array, I read my grades. By the time I finish reading my grades, I will not have an idea about how the students are, what are the standards of my students. In that case, I tend to group the data. And I'm sure you know, grouping means putting together, right? Now the point is how I group my data, how I put together my grades, okay? Don't forget, report, upper administration, etc. Well, ladies and gentlemen, grouping the data is into what we call classes or intervals. Classes or intervals. You all know what an interval is, for sure. An interval is a range of numbers with a lower limit and an upper limit. A range of numbers with a lower limit and an upper limit. Now, whenever we want to group the data into intervals or classes or class intervals, okay, there are a few requirements we have to follow. But before that, before the requirements, no, actually, let's mention the requirements. First, one, the intervals have to be chronological in order. Chronological means one after the other. Next, there should be no gaps between classes. Gaps means an opening. Huh? It's forbidden. There should be no gaps between classes. Third, the lower limit of a class always belongs to the class. The upper limit belongs to the next higher class. So if I'm talking about grades, 40 to 50, 50 to 60, 60 to 70, etc., for the class 60 to 70, a grade of 60 will belong to that class. But a grade of 70 will belong to the next higher class, which is what? 70 to 80. And as I mentioned before, is someone asking a question? I said chronological in order, ascending order. I told you preference goes to the ascending order. All right. So let's see some, let's crunch some numbers. As I said, I'll refer basically to grades and students and OSB and so on and so forth. In grouping data, there are two major decisions we have to make. Two major decisions. One, how many classes, how many intervals should we have? 10, 20, 100, 5, 10, whatever, okay? Number of classes. The second very important decision is how wide a class should be. The width of a class. Usually we don't say how big a class is, okay? We say how wide a class should be. Two very important decisions the statistician, the decision maker has to make before she starts grouping the observations or the data, okay? Unfortunately, there are no, I call them God-given rules that we can follow. However, we have some guidelines and we can follow these guidelines to deal with our problem. We have some help in the form of I call it an equation that we can refer to whenever we want to group the data. Let me put the equation on the board and then we shall discuss it. The equation says number of classes, okay, number of classes can be found by taking the highest observation, subtracting the lowest. Remember, we have an array, so very quickly we know the highest observation and we know the lowest observation. So we take the highest observation, lowest observation. W stands for the width of a class. Now we know that whenever we have one equation, we can have only one unknown. And that unknown is the left-hand side, i.e. the number of classes. So everything here has to be known. There's no problem with the highest observation and the lowest observation. It's there, it's in the array. I mean, it's in front of us. W. Well, someone has to decide for W. Statistician or someone else, somebody has to give us a value of W. Now we plug in the values, okay, we make the calculations, and we get the number of classes. Suppose we get 8.32. We got 8.32. Of course, it goes without saying that we cannot have 8.32 classes. Impossible, right? Rule, and this is going to be our rule, okay, for this course. Whatever the decimal, I mean, I put an 8.32, okay? We need an integer number for classes. It's not the rounding procedure we are used to. I mean, 8.32, we don't round it to 8, okay? We round it to the next higher integer. Next higher integer. That means we are going to round it to 9, okay? So that is a rule we are going to follow. Of course, if we get an 8, that's it. It's a whole number. It's an integer. No problem there. But if we get an 8.32, then we're going to round it to the next higher integer, namely 9. Now, ladies and gentlemen, the same equation, right, can be used to find the width of a class. Okay, we can use the same equation to find the width of a class. Again, highest observation minus lowest observation for a given set of data, it's always there, they are there. Number of classes. So the number of classes will have to be determined. The statistician, the whatever decision maker has to have a number. Now, for the width of a class, the same rule will be followed by us. Okay, so if you get an integer value, that's it. But if you get a fraction, I mean, a number with decimals, you round it to the next higher integer. These rules are quite simple, right? Always, integers are fine, whether we're talking about width or we're talking about the number of classes, okay? Integers are integers, no problem there. Decimals, fractions, or whatever, you round it to the next higher integer. Very simple rule, okay? Now, one thing though. Suppose I want to find the width of a class. I have, of course, the highest observation. I have the lowest observation. Number of classes. I don't know what to do with the number of classes, right? Well, I cannot have one equation with two unknowns. Impossible. So somehow I have to get a value for number of classes. There are several ways, ladies and gentlemen. However, we are going to follow or to use, if you like, the 2 to the k rule. The 2 to the k rule. Now, I will leave it for the next session, the 2 to the k rule. By the way, ladies and gentlemen, please, you start reading your book, all right? Don't accumulate too much material. You will face difficulty, right? The 2 to the k rule is in the book. So I will give you some time to go to the book and get to know what the 2 to the k rule is. Once we get the 2 to the k rule, by the way, is for the number of classes, okay? Once you get the number of classes, you plug in, and as before, you find the width of a class. Now, whenever we are using this particular equation, all right, to find the width of a class, all right, then the classes will be of equal width. They have all the same width, okay? Now, in real life situations, by the way, sometimes we are obliged to have classes with unequal widths, definitely, right? However, in our course, we're not going to face such situations. So basically, we're going to deal with classes of equal width. But just keep in mind that there are many situations where we have to use unequal classes, right? We have to use classes with unequal widths. So keep that in mind. Okay. Let's get some easy numbers, see what we're talking about. So as I said, I will refer, by the way, throughout the course, I refer to us, OSB, students, our administration, the dean, etc. I always do that because it's near. We are, in it, in OSB. All right, let's say, so we're talking about grades, classes, or intervals. Okay, let's say we have 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, and 90 to 100. So let's get some grades or numbers. Frequencies. Frequencies, of course, refers number of occurrences, number of times occurring. Okay, so let me put some numbers here. Let's say 5, another 5, and a 10, and a 25. Great, so I got to 100 because in class, of course, I try to use simple numbers. Okay, in real life situations, it's not as simple as that. By the way, some students think that all the times when we deal with data, we should have 100 observations. Of course not, definitely not, okay? But for, I say, classroom consumption purposes, easy numbers to present the ideas quickly and easy. Okay, now let's see. So I have my 100 students, okay, and the frequencies are there. Let's see, what does a frequency of 5 mean here? It means I have 5 grades. I'm not interested in the people. I'm interested, my characteristic of interest is grades. So I have 5 grades from 40, lying between 40 and 50, but not 50. It could be 49.99, but not 50. 5 means 5 students or grades between 50 and 60, okay, but not 60, and so on, all right? The only time the upper limit of the class belongs to the class is the last one. I mean, if I have 2 grades or 3 grades that are 100, I don't have a class for them. It will be, or they will be, in the class from 90 to 100, okay? And it's a rule that the total number of frequencies should always be equal to the total number of observations, i.e. if you're dealing with a sample, then it should be the sample size. Good, notations. Capital N usually denotes the size of a population, and small n denotes the size of a sample. These are universal notations. I mean, whenever you see small n, you don't ask, what is the small n? No, it is the size of a sample. Okay, and we shall deal, as we said, basically with that. So 100 grades. Okay. I have good information about the standards of the students, of my students. I mean, 5 are, I will hope that I don't have such a category. Very, very bad, bad, but of course I have some also very good students. So grouping the data gives me enough information. One disadvantage though, with grouping the data. Grouping group data versus ungrouped data. Remember, the ungrouped data is the individual grades. I have them in front of me. I'm looking at them. But with group data, a disadvantage is that you don't know the actual observations. For example, if I have 40 to 55 students, okay, 5 students that have grades between 40 and 50, I don't know the actual grades. One of them can be a 40, 2 can be 41, 1 can be a 49, another one can be, I don't know, a 45. I don't know the details. What difference does it make? 40 to 50 is a catastrophe. So whether the grade is a 42 or a 45 or a 47, it doesn't make much of a difference. I mean, if I'm going eventually to present my report to the upper administration, the dean or whoever, conveners and so on and so forth, what difference does it make if these 5 grades are 40, 42, 49, etc.? They know that there are 5 students, no good, catastrophic. Okay, so although we lose information with grouping data, the gain from grouping is much, much, much more than what we lose, right? And by the same token, I have 15 students from 90 to 100. What's the difference between a 90 and a 93? Excellent. both grades are excellent. So it doesn't make much sense to say, I'm losing the information. No, no problem. Okay. The next idea we want to deal with is what we call relative frequencies. Relative frequencies. I'm sure you all know what relative frequencies are. Relative frequencies are, or for a class, is the frequency of that class divided by the total number of observations. Okay? Frequency per class, number of observations per class, divided by total number of observations. So let's put them. Here we have now it's a must and a rule that some total of all relative frequencies should be equal to 1. Okay? Sum total is equal to 1. And I'm sure you know that relative frequencies, the idea of relative frequencies is or forms the basis for probabilities. You know that, I'm sure. Okay? Now, we have 0.05, 0.05, etc. By the way, we should, whenever we are analyzing the data, okay, we have to take at least 3 significant digits after the decimal. All right, 3. Now, as I said, these are nice numbers, but in real life situations, you might get something like 0.319328, for example. Okay, 0.319328. Okay, I'm not going, we don't keep all of these, right? So we try to simplify or round, rather round. Okay, we start from the right. Okay, let me put this here so that you can see it. We start from the right. 8 makes this a 3. 3 doesn't influence, of course, the 3. The 3 doesn't influence the 9. So eventually, my value will be 0.319. So right to, yes? Okay. Here I have put 2 significant digits after the decimal because the total is 100. So don't have that. All right. Now, relative frequencies. The information driven from relative frequencies. Don't forget, you are getting these numbers, you are preparing this table, but eventually you're going to interpret. The major role of the statistician is interpretation, explanation, because all of these numbers are obtained via some sort of a device, whether it's your calculator or it's a computer or whatever it is, okay? So our role is interpretation. So let's try, for example, to interpret the first one, 0.05. When we interpret, we start interpreting, we don't say 0.05 of the students, okay, have grades between 40 and 50. We say 5% of the students have grades between 40 and 50. So we revert to a percentage form of presentation, okay? When you have a bank account and they give you a 4%, you see automatically I said 4% interest rate. you don't say, the interest rate I'm getting is 0.04. You never say that. It is true. What you're getting is a 0.04, but you don't say, I get, or they're giving me a 0.04 interest rate. You say they are giving me, or I'm getting a 4% interest rate. So whenever we want to interpret automatically, it's a percentage presentation or form. Okay. Next, the idea of cumulative frequencies. The idea of cumulative frequencies. Cumulative, from to accumulate. Accumulate means add. By the way, I'm sure most of these ideas, you know them, right? They're not new, but anyway, we're going over them quickly. Cumulative frequencies refer to what? Cumulative frequencies refer to the sum total of all frequencies below the upper limit of a corresponding class. So let's have a look. Let's take the first one. All frequencies below the upper limit of the corresponding class. The corresponding class, 40 to 50, upper limit is 50. All frequencies below 50. So we have 5. Now, the next one. We have the class from 50 to 60. Upper class is 60. So the cumulative frequency for this particular class will be what? Sum total of all frequencies below 60. So that is what? Of course, the 5 of this class and the 5. So let's get them. We have 5, 10, 25, 50, 85. The last entry in a cumulative frequency column should always be equal to the total number of observations. Okay. Last but not least, let me make this here. Cumulative relative frequencies. By the way, interpretation, you see there are 10 students, grades less than 60. There are 50 students, grades below 80. Right? That is the interpretation. Now, cumulative relative frequencies, it's precisely what it says, accumulate relative frequencies. So we have 0.05, 0.10, 0.25, 0.50, 0.85, and 1.00. Last entry in a cumulative relative frequency column is always 1. All right? And 25% of my grades are below 70, 85% of my grades are below 90. That's the interpretation. Now, ladies and gentlemen, a very small table, lots of information, right? Lots of information, okay? It's very clear that I have no grades below 40. Okay, of course, there are no grades above 100. That goes without saying. Within each class, I know how many students. I know the percentage of students, okay? And then, of course, information for below a certain value. The idea of cumulative frequencies and cumulative relative frequencies. Beautiful. Just a small table, lots of information. As I said, the only thing we lose is the individual grade. No problem. No problem. Actually, no problem. We said that. Okay? All right. You know from math, specifically your math courses, that graphs are used always. Tremendous. Okay? Why? Because a graph is a visual, graphical presentation. It's a pictorial presentation, if you want, of your data. There are many types of graphs, right? And yeah, we are going to look into the most important ones, with which, by the way, you are also familiar. So I'm going to leave these cards. And here we go. Uh-oh.
$35 and $15.
35 and 15. Thank you. Yes.
You're welcome.
Perfect. Okay. Let's put the graphical presentations first that we are going to deal with. They are by no means the only ones. And you know, nowadays, I say with the computers, you know, all sorts of, I don't know, colors and shapes and so on and so forth, but we want to know the basics. All right, so let's see. Graphs. We shall talk about the histogram, the frequency polygon, frequency curve, okay? And then we shall talk about the pie chart, and the bar chart. As I said, they are by no means the only ones, they're the most important ones. All right, let's get to the histogram, okay? If I were to ask you face to face what a histogram is, I would get more or less quite a myriad of definitions. Anyway, you all know the histogram, so let's try to give some sort of a correct definition of it. A histogram, ladies and gentlemen, of course, it's drawn on a plane or in a plane. So we're going to draw a histogram of our data. On the horizontal axis, we will have the characteristic of interest, which in our case is grades. And on the vertical axis, we have frequencies. So let me see, this is 40, 50, 60, 70, 80, 90, and 1. And on the vertical axis, and it's, here we go. By the way, needless to say that whenever we are drawing any graph, I mean, if we're drawing it manually, you have to be very precise. You have to draw to scale. But of course, we can always nowadays use our computers to draw graphs. Okay. So what is a histogram? It's basically a collection of rectangles, okay? We all know that a rectangle, geometry, a rectangle is identified by its base and its height, right? Once you know the base and the height of a rectangle, you have identified the rectangle. So, Ella, it's a collection of rectangles, right? Whereby the base is a class interval. the base is a class interval. Height. Now, I'm sure some of you are thinking the height is equal to the frequency of that class. Well, ladies and gentlemen, I will say both a yes and a no. Whenever we have classes of equal width, then the height of the rectangle is equal to the frequency of that class. However, whenever we have unequal classes, then the height of the rectangle is not equal to the frequency of that class. And what is it equal to? How do we find it? Never mind, since we're not going to face it, I'm not going to complicate your life. So in our case, the height of the rectangle is going to be equal to the frequency of that class, okay? So think of rectangles, and this is of course not statistics the way I'm going to say it, sitting on the classes or the intervals, right? Now, 40 to 50, okay, and another 5, and then we have the 15, and then we have the 25, uh, 35, and a 50. I deserve a 0 for that graph. Anyways, here, well, if we look at this rectangle, by the way, as you can see, the bases are the classes, the heights are the frequencies. By the way, something very important, I have a width of 10, okay? And of course, this is the origin 0, right? The scale is 10, 10, 10. As you can see, from here to here, doesn't make any sense. This is not a value of 40. So ladies and gentlemen, so that I don't go to the other side of the board, you break though, and this is what you see usually in textbooks, etc. I'm breaking here, I'm sort of compressing, all right, so that I don't have bizarre looking graphs. Suppose I erase this, I erase the table. My histogram, ladies and gentlemen, will give me exactly the same information as my table. It's very clear that I don't have any grades below 40. I should have had a rectangle there, right? No grades, of course, above 100, goes without saying. I have 5 grades between 40 and 50, 5 grades between 50 and 60. I have the bulk of the grades between 80 and 90, as you can see the height of the rectangle. The second bulk is between 70 and 80. So the bulk of my students' grades are between 70 and 90. Lots of information, actually the same type of information coming from my table. Perfect, perfect. And of course, if it's accurately drawn, it's beautiful. Graphs are beautiful to look at. Okay, let's see what the frequency polygon is. We obtain a frequency polygon, okay, by joining the midpoints of the tops of the rectangles. The midpoints of the tops of the rectangles. Here we have join them. When I say join them, it's literally join them. Don't manipulate, don't do anything. Just join them. Here we go. Here, 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 here. Okay. All right. It's just by the ruler. Literally join them. Okay. What? We know that a polygon, you know that a polygon is a closed figure. This is not a closed figure. So we have to close it. You see, the red is the polygon. We have to close it. All right? We do that by following a very simple rule. We take half the width of a class, half the width. I have a width of 10, half of it is 5. I move away from here, from the lower limit of the first class. I move away 5 grades. I join. Upper limit of the last class. Again, I move away 5 grades. I join. That is a frequency polygon. Last but not least, ladies and gentlemen, for today's session is the frequency curve. When we say curve, a smooth figure comes in front of our eyes. When you, I'm just going to say no further, I mean, I'm not going to say further. When you smoothen a polygon, you get a polygon. Okay? Now, a curve doesn't have to pass through the midpoints of the tops of the rectangles. Just take it for granted. And when I smoothen the figure, the polygon, I will get a curve. And by the way, what we see in textbooks, the histograms, we see a lot, but we see the curve. The curve is presented. We bypass sort of the polygon. All right. Okay, ladies and gentlemen, this is it for today. As I said, start reading your chapters. I think you should read the first something like 3 chapters. Next time we meet, which is next Tuesday, all right, hopefully the IT team will have given me the recorded videos. I will post them as soon as I have access. And I will post, of course, this session as well. So you can go back to the videos, this one and others, okay? And you study well. See you next time. Take care.
Hello.
Yes.
Just what's the name of the book?
Please lower your microphone or something because it's giving me an echo. I cannot hear it. Yes, please go ahead.
The name of the book.
I didn't get you. One more time.
The name of the book.
Oh, the name of the book is, good question. It's Statistics for Decision-Making Purposes. It's by Gobner, Shannon, and Fry. It's a very sexy looking book. It's black. Anyway, if you go to the bookstore and you say the book for Business 200, there's no other book. It's the 10th edition, I believe. The background is black with lots of colors and, you know, on it.
Okay.
So
Thank you.
One more time. You need a book.
Yes.
You need a book. And you read the book. I'm sure some of you are thinking or they want to ask me, Miss, I take notes. Is it okay? Is it enough? The answer is a definite no. A definite no. Why? Because there are topics that are required and I will not be able to cover in the classroom or in the videos or whatever. Yeah. You need the problems book, okay? And I don't know if I say something wrong, not intentionally, of course. Your reference is the book. You need a book. Clear? Okay, I'll see you next time, hopefully, and study well. All right? Take care.